And there is another part, which is part C. And I think the fact that this is a basic condition is quite obvious in this part, with the presence of OH minus here. Okay, so we have 0 for aluminium, -2, +7 for manganese, -2, +4, and this is +1, -2, +3. The overall charge of this ion, which is AlOH4, the overall charge is -1. So the negative here actually is supposed to be on the whole thing. Now it looks a little bit hard to see. There should be an increase in oxidation numbers for aluminium from 0 to +3. So this is going to be the reducing agent. And manganese has gone down from +7 to +4, so this is your oxidizing agent. Now it may look like you can split the aluminium hydroxide, but this is actually not an ionic compound. It is already an ion. This is also an ion, so you can't split that. This is solid, so also cannot split this, which means that you actually can't split anything. This is actually a good example of how you could speed things up just by observing. I just want to remind you that this is under basic condition, which is another way of saying that there should be some OH minus present. Yes, OH minus ion present, AQ present, which if you wish to use it, and you could speed things up in this particular instance if you are aware of that. So I'm going to start with the oxidation half equation, which go from Al solid going to AlOH4 minus aqueous, and the aluminium itself is already balanced. I think already you can see that you need to balance the hydroxide. Now you could go through cohes and then convert the product to a basic condition, or you can just do this if you realize that a hydroxide ion will be present in this solution, which makes life a lot easier for you, I think. And now the charge on the left side is 4 minus, so I just need to add 3 electrons to balance the other side, which I think agrees with the change in oxidation number from 0 to +3. For reduction, I don't think I could get away with just adding hydroxide, so I may have to do it the long way this time. So I have MnO4 minus going to MnO2. So yes, I'm going to use cohes. I need to add 2 H2O. The manganese already balanced. 2 H2O, 4H plus, which means that the charge on this side is 3 plus in total. I need 3 electrons, which does agree with the change in oxidation number from +7 to +4. Now I am going to convert this to basic conditions by adding hydroxide. So 4 OH minus on either side. This is 4 H2O. I'm just going to write the final product here, just to leave myself a little bit of room to write the overall equation. So MnO4AQ, you should be able to cancel some of the water out. There's 4 on the reactant and 2 in the product, so you should get 2 left. And 3 electrons going to MnO2 solid and 4 hydroxide ions. Okay, so that's the reduction. Luckily, you have the same number of electrons being changed here, so I could just add the 2 half equations together without having to change anything. I definitely need to simplify some certain things. So aluminium, I'm going to use MnO4 minus first. I tend to leave the water and any ion, like hydrogen ions or hydroxide ions, towards the end, just so that I know that, well, just so I could simplify it, cancel things out if I have to. Because I think you should actually be able to do it in this case. Yeah, so 4 hydroxide reactant sign 4 on the product, so it looks like you could just cancel it out. The charge of the overall equation at the moment is balanced, it's minus and then minus. Although I find it a little bit, I'm a little bit weirded out in terms of things not being balanced, because wouldn't you have, oh yes, there's still 2 water, that's why. because I was trying to balance the oxygen. So the water is actually from here. The hydroxide cancel out, the water has to go down to the overall. So now you should have 6 oxygen on the reactant side and 6 on the product side. And that is the end of question 4c.